All right. This is the second part of our series on, I guess, the chapter on biological macromolecules. We left on um, one of the chemical tests for food science. It's basically the Benedict's test principle. Uh, yeah, the color of the precipitate, the final color, to prove that there are actual sugars in a solution. It should you know that there are a lot of sugars if the color of the precipitate is brick red. Um, there's a lot more knowledge on this, um, but yeah, I don't really have much time to elaborate on each. Probably in the next video. But for now, we'll be going with the lesson on lipids. This is the um, biological molecule that isn't large enough compared to the other three, which are basically carbohydrates, amino acids, and nucleic acids. Uh, so lipids are not true polymers, and they are not big enough to be macromolecules. I just said that. And the reason why lipids are hydrophobic is because of their molecular structure. Hydrophobic means they avoid water. So yeah, they are mostly made of hydrocarbon regions with relatively nonpolar CH or hydrocarbon. I think this is hydrocarbon. But yeah, CH bonds in the hydrocarbon chains of fatty acids. So yeah. Lipids are divided into three types. We have fats, or in other words, another way of saying it is triglyceride or triacylglycerol. Any of these terms are the same as fats. I'm not sure why they came up with the term, but yeah, it looks fancy, triglyceride or triacylglycerol. The second type is phospholipids, and third is steroids. Let's first go with fats. Fats are not true polymers. They are large molecules from smaller molecules by dehydration reactions. And in the event of making a fat, we make a single glycerol and three fatty acids. So glycerol consists of alcohol, and each three carbons, each three carbon, sorry, each carbon, which is basically three of them, they all have a hydroxyl group. And for three fatty acids, each is 16 to 18 carbons long, and in one edge, the carbon has a carboxyl group. The result of the dehydration reaction is an ester linkage, basically the bond of hydroxyl and carboxyl group. The major function is energy storage in adipose cells. Now, the levels of triglycerides basically have two, saturated fatty acids and unsaturated fatty acids. For saturated, one example is stearic acid. It's basically known as the fatty acid without double bonds between carbon atoms. So imagine this. So because because the structure is saturated with hydrogen, that is because there is no double bond at all. The appearance at room temperature is, the phase of the physical phase of a saturated fatty acid is solid. So yeah, unlike comparison, unsaturated fatty acids, one example is oleic acid. It is liquid at room temperature because of the presence of one or more cis double bonds. So the double bond basically reduces the amount of hydrogen atoms. So yeah, if you can see here, in one carbon atom there are 4 hydrogens, but upon the but in the presence of a double bond, we have at least 3 hydrogens left. So 1 hydrogen is removed. Several types make unsaturated fat. So let me tell you this already. saturated fatty acids, these are the unhealthy kinds of fat. It can cause cardiovascular diseases such as atherosclerosis. Sorry if I mentioned it incorrectly, but yeah, atherosclerosis. Basically, the buildup of plaque in the arteries, or generally the blood vessels. And for unsaturated fatty acids, because they are liquid, they do not cause any plaque in the blood vessels, therefore they are healthy. One example is olive oil. So, yeah. Um, for phospholipids, um, one thing you have to know is that they are essential for cells, as they are major constituents for cell membranes. Um, Remember the term phospholipid bilayer. It basically um, it's basically a really big part in the cell membrane, regardless of regardless if it's an animal cell, a plant cell, or a bacteria cell. All cells have a cell membrane. Anyways, so in the making of a phospholipid, um, we need glycerol, and just the same as a fat, but this time, instead of 3 fatty acids, we have 2 fatty acids only. And the third hydroxyl group is joined to a phosphate group. You don't really have to memorize that, but yeah. Examples of phospholipid are as follows: choline and phosphatidylcholine. For the two ends of a phospholipid, one is a hydrocarbon, which consists of it's basically a tail, and it's non-polar and it's hydrophobic. For the phosphate group, it's basically the head. It's polar and it's hydrophilic. So altogether, they form what is called a phospholipid bilayer. So it forms a boundary between the inside of a cell and the external environment, or in other words, the cytoplasmic side and the extracellular side. So they establish separate compartments within the eukaryotic cells. Eukaryotic cells are the ones with a nucleus and other membrane-bound organelles, if I'm not mistaken. Just know that eukaryotic cells have a nucleus, unlike prokaryotic ones. So, for steroids, they are lipids with 4 fuel rings in its carbon skeleton. The kinds are distinguished by the specific chemical groups in the rings. So basically, a steroid is a lipid ring, and cholesterol, in particular, is an example of a steroid. It is a component in animal cell membranes. It is a precursor for the synthesis of other steroids, and for vertebrates, they are made in the liver. Where particularly in the liver, there is something called the endoplasmic reticulum, divided into 2 things. One is rough and one is smooth. For the rough ER, this is where you find some of the ribosomes that make protein. And those proteins get transferred to the Golgi apparatus for protein folding. And for the smooth ER, this is the site for the genesis or the creation of cholesterol. So yeah, that's everything you have to know. For the synthesis of other steroids, as well as sex hormones, cholesterol is not only capable of making other steroids, it's also capable of making sex hormones such as estradiol and testosterone. I think testosterone is both for male and female, but for estradiol, this is something related to women's ovaries, if I'm not mistaken. So, yeah. Fats separate from water since water hydrogen bonds with one another, excluding fats. I think it kind of makes sense. Fats are are hydrophobic, and water is literally water, so it's hydrophilic. So if you mix a hydrophobic with a hydrophilic substance, they don't mix together, basically. And that kind of concept is going to be useful later in our discussion on cell membrane, how nonpolar and polar, basically how hydrophobic and hydrophilic molecules get transported across the cell membrane through either active or passive transport. So probably that's going to be in the next video, but for here, for this one, we're going to focus on lipids particularly. So fats, so wait, I've already mentioned that. Atherosclerosis, I mentioned this earlier. This is the result of a diet rich in saturated fats, the fats that are solid at room temperature. These are also the fats without any double bonding, which allows hydrogen to solidify molecules as a whole. So this is explanation as to why saturated fats are solid at room temperature. The hydrogen, the saturation of hydrogen plays an important role in making it solid. So hydrogenating vegetable oils, naturally, there are certain vegetable oils, if not all, that are unsaturated, which are basically liquid at room temperature. But from the word hydrogenating, this is basically the addition of hydrogens, or addition of H or hydrogen atoms. So what used to be a healthy kind of oil, it's now, because it's already hydrogenated, it becomes saturated or unsaturated, but this time, instead of having cis double bonds, where is it? Right there. Instead of having cis double bonds, it is unhealthy because now it has trans double bonds. There's a difference between cis and trans double bonds. Cis double bonds are the ones located in unsaturated fats that are healthy. They're still liquid at room temperature. But for unsaturated fats that are hydrogenated, the cis double bonds transform into trans configuration, which makes it closely similar to the structure of saturated fats. Let's search. There it is. Let's find an image. There it is. This is what we were looking for. So basically, we all know that saturated fatty acids are solid at room temperature. So you can see that the molecular structure is straight. I'm sorry about that. So for unsaturated fats that have cis double bonds, basically oleic acid or olive oil, they are bent. The structure is bent because they are liquid at room temperature. But upon the process of hydrogenation, undergoing hydrogenation, the unsaturated fat becomes trans fat, which makes it no different from saturated fatty acid in terms of being solid at room temperature. So, yeah. I basically explained what's mentioned here. Cis double bond found in unsaturated fatty acids, trans double bond, unsaturated trans fat result from hydrogenation of saturated fatty acids. This is supposed to be on, I think. Yeah. What used to be healthy, upon hydrogenation, it became unhealthy. So, trans fats, it's basically this one, unsaturated fats with trans double bond. It causes coronary heart disease, Not sure what it is, but yeah, I think you get the point. It causes coronary heart disease. For adipose cells, they are the ones that store fats for energy. The adipose tissue cushions vital organs. It serves as body insulation by the fat layer. So, for the two ends of a phospholipid, hydrocarbon tails are hydrophobic, or in other words, non-polar. They're associated with each other. You always have to remember that. Hydrophobic is non-polar. Hydrophilic is polar. That's going to be important on our next lesson in terms of active versus passive transport. And these two ends, when phospholipids add to water, they self-assemble into a bilayer to shield the hydrophobic tails from the water. Basically, this is the interior, this is the exterior. Let me draw something. So say this is the cell membrane. The hydrophilic heads are located here, and the hydrophobic tails are located in the middle. There you go. There you go. So let's say this is the extracellular side. So basically, this is the outside of the cell. This is the cell membrane. This is the inside, the cytoplasmic side. So when phospholipids are added to water, this by the way is the entire phospholipid bilayer. It comprises majority of the cell membrane. It self-assembles a bilayer upon the presence of water to shield what is hydrophobic, the purple tails. It basically shields them from the water. What shields them? The hydrophilic heads. Heads, I mean circles. So I hope you get the idea. We'll be discussing more about this model later. So the existence of cells depends on the properties of the phospholipids. And one thing you have to know also is that an increased level of cholesterol in blood can also contribute to atherosclerosis. One particular example of bad cholesterol is called an LDL, or a low density lipoprotein. We're going to discuss that in the so how do you call this? Endocytosis part of active transport. So that's going to be the next video. So there's also an Edpuzzle video. An osmosis video on fats. It's basically a concept in biochemistry. Fats are essential for a healthy diet. Fats contribute to taste and texture of foods. Fats serve as a major source of energy and are critical to cells and tissues. They help absorb vitamins and get converted to prostaglandins, which help cells communicate. So the building blocks of lipids, particularly fats, they basically consist of glycerol and fatty acid. Again, for fats, we need where is that? For a fat, we need glycerol and 3 fatty acids. For a phospholipid, glycerol and 2 fatty acids. And for steroids, wasn't really mentioned. Anyways, yeah. So this is basically ester linking. So ester linkage. If I got it right. Yeah, result is ester linkage. Hydroxyl group plus carboxyl group. So yeah, water is released. I think dehydration reaction also is applied in the synthesis of in the combination of glycerol and fatty acids, the linking of the two things. So yeah. we have a monoglyceride, a diglyceride, and a triglyceride. Um, Similar to how we label or classify monosaccharides, disaccharides, and polysaccharides. Uh, this one, these terms are under the context of lipids, or basically fats. So linking glycerol to fatty acid only one time, so only one linkage. Um, Linking for diglyceride, we have two fatty acids, so I think this is a phospholipid. And for triglyceride, this is fats. These are basically fats because there are three fatty acids and one glycerol. One glycerol is equivalent to 3 carbon atoms. And I guess this is the hydroxyl group, if I'm not mistaken. So since globules are formed, triglycerides are hydrophobic. These are basically fats. Fats are hydrophobic. For categorization, um, you call a lipid short chain if it only consists of 2 to 5 carbons. You call it medium if there are 6 to 12 carbons. And you call it long chain if there are 13 or more carbons. I wasn't able to exactly illustrate the medium and long chain, but yeah, you'll find many illustrations in the internet. For the types of fatty acids, we have saturated and unsaturated. For saturated fatty acids, these are fatty acid chains with only a single bond. I mentioned this to you earlier. Saturated fatty acids saturated fatty acids include as much hydrogen atoms as possible, since there are only single bonds. So imagine a carbon atom and then there are 4 hydrogens. Add another carbon atom and we have something like this. There are all single bonds connecting each. Compare that to unsaturated fatty acids. We'll draw the same thing, but this time with a double bond. So let's say we have a double bond here and here. So because a carbon atom can only connect to 4, so we basically have 4 hydrogen atoms per 2 carbon atoms. Compare it to this illustration. 2 carbon atoms for 6 hydrogen atoms. So there is a big difference upon the presence of at least a double bond, a single double bond. So, yeah. Because unsaturated fatty acids are not saturated with hydrogen atoms, there is a bend in the molecule which makes it liquid at room temperature. So yeah, it's not saturated with hydrogens. The longer the chain for saturated, the more likely it is solid. So because of the saturation of hydrogen atoms, the fat is solid at room temperature. That goes for saturated fatty acids. Now, for unsaturated, there are 2 things you might want to know. We have monounsaturated, that means there is only one double bond. But for 2 or more double bonds present, it's called polyunsaturated. I'm not sure why they did not mention diunsaturated, but might as well just memorize whatever is mentioned. But it's good to open that up to your teacher if you have the chance. So for omega, we'll be mentioning omega-3, 6, and 9. For omega-3, it's usually polyunsaturated. They basically include alpha-linolenic acid, or ALA. Plant sources, you can find these in flax seeds and walnuts, canola, and soybean oil. Secondly, we have icosapentaenoic acid, or EPA. and docosahexaenoic acid, or DHA. These are marine sources. You get these, oh, sorry. Not sure if this is called vitamin or mineral, but uh, you get EPA and DHA from marine sources. These are produced by microalgae. So for omega-6, usually polyunsaturated, uh, means consisting of two or more double bonds. They basically include linoleic acid and arachidonic acid. For linoleic, basically oils, and arachidonic is for fish, meat, and eggs. So for omega-9, they are usually monosaturated. It only has one double bond, and it can be made by the body. It can be found in canola, olive oils, and almonds. One example is oleic acid, which is unsaturated, which makes sense because it says here mono, unsaturated. Now, for the fats in double bond configurations, we have two. One is cis and one is trans. I've already mentioned this to you earlier. For cis unsaturated fatty acids, functional groups are on the same side and they are liquid at room temperature. So this is the healthy kind of double bond in unsaturated fatty acids. And on the contrary, for trans unsaturated fatty acids, they are solid at room temperature, just like saturated ones, the ones that you see in burgers, pizzas, fast foods, basically. And functional groups are on the opposite side. Not sure if you still have to memorize these, their corresponding categories, but yeah, again, review according to what you have to review. Now, trans fats are the result of hydrogenation. I mentioned about this too. So removing all double bonds, and at the same time, upon the removal of double bonds, adding hydrogen atoms. The less double bonds, the more hydrogen atoms. The more double bonds, the less hydrogen atoms. The less double bonds, the more hydrogen atoms. So there is something called partial hydrogenation. It basically removes most of the double bonds. It happens in the animal digestive tracts and in liquid oils. So there are certain partially hydrogenated oils that have recently been banned in North America. Oil companies, uh, wait, cooking oil companies that make their products partially hydrogenated, there's been this policy that bans them since partially hydrogenated oils are really unhealthy. So yeah, they contribute to coronary heart disease and among many other cardiovascular related problems. So peanut butter, 75% calories from fats, globose bile salts from liver, help lipases turn triglycerides into free fatty acids and monoglycerides. Lipase are basically enzymes in saliva and the stomach. They are secreted or created by the pancreas, just like how am I supposed to say this? Pancreatic cells produce or secrete insulin for maintaining blood sugar. And for lipase, they are also made by the pancreas, I suppose. And it contributes in breaking down free fatty acids and monoglycerides. And all these two, free fatty acids and monoglycerides, they both self-assemble into mixed micelles, which are divided into two things, the hydrophobic interior and the hydrophilic exterior. So yeah, I skipped this part, by the way. I didn't notice that, but anyways. The impact of fats on health. Polyunsaturated fats serve as a precursor to hormones, for instance, prostaglandins, and they reduce total LDL cholesterol. Yes, I mentioned about LDL earlier. LDL basically stands for low density lipoprotein. So polyunsaturated fats, we know that this is healthy. Um, it reduces the bad cholesterol, which in turn lowers our heart disease. And it's basically a long chain of omega-3, which lowers plasma triglycerides. And yeah, particularly DHA focuses on the development of the eyes and the brain of infant children. So vasodilator lowers blood pressure. For saturated for saturated fats, they generally keep consumption low, and for the effects on cardiovascular health basically depend on type and the nutrient that replaces it. For recommendations, we have the following: 20 to 35% of calories as fats, and less than 10% from saturated fats. You consume trans fats as low as possible. So yeah, that's it. Next video, we'll be discussing proteins.